Hi everyone, in this video I'd like to work through calculating the value of the derivative at a point, so the slope of the tangent line, and then we'll practice finding the equation for the tangent line again, and then I want to look a little bit at this particular function. I think it's kind of an interesting one, so just a little extra tidbit at the end. Okay, so the function given here is a radical function. It's kind of a messy one. That's one of the reasons I wanted to walk through this. You're hopefully getting pretty good at simplifying difference quotients, but this one is a little bit sloppy. So our function is a of k, and when you input the k, it will give you back the square root of k squared minus 1, and I'm hoping to find a prime of -2, which we should immediately, when we see the prime, go for the limit definition. So it's going to be the limit as h goes to 0 of a of -2 plus h minus a of -2 all over h, which, I don't think that's going to fit, is going to be the limit as h approaches 0. So now I'm going to go ahead and plug these things back into my function. When I plug -2 plus h into my function, I get the square root of -2 plus h squared minus 1. When I plug a -2 into my function, I get the square root of 4 minus 1, so the square root of 3. And I'm supposed to divide all that by h. Okay, so I have the 0 on the bottom, and similarly in the top, if the h goes to 0, I get the square root of 4 minus 1, which is the square root of 3 minus the square root of 3, so 0 over 0. So algebra is a good plan, and the algebra in this case is to try and get rid of those radicals. I'm going to do a tiny little bit of scratch work here because I feel like I didn't leave myself quite enough room for this messy one. So I'm going to go ahead and multiply this out. I'm going to say I get a 4 plus, nope, minus 4h plus h squared minus 1. So underneath that square root, that's what I'm really going to have. And I can even combine the 4 and the -1 and see that's a 3. Okay, so I want to multiply by the conjugate to get rid of the square roots. And the conjugate is going to be this 3 minus 4h plus h squared under the square root. And then it'll be a plus the square root of 3. And we have to do that to the top and the bottom. Okay, so this is the really messy part. We're going to walk through this. And if you can just see how it's going to work out, that's great. You can just skip to it, but I still want to show some work here. Let me see if I can find a color that's going to show. So the top especially, you need to make sure that you look at that as a FOIL. So when I multiply the first two together, they're actually the exact same things. That square root of 3 minus 4h plus h squared multiplied by itself, which is going to eliminate the square root. So we're going to have a 3 minus 4h plus h squared out front from our first, so that's first. The outside is not particularly nice. We get that square root of 3 minus 4h plus h squared multiplied by the square root of 3. So we're going to have plus, and if you want to, you can mush that all into one square root. You don't have to, but that is legal. When you're multiplying roots, you can combine them. It stays a product. It's just a product under the root. So that's our outside. The inside actually ends up being the exact same thing, but it's got a minus sign attached to it. And then the last is square root of 3 times square root of 3, which is 3, and then that'll have a minus sign attached to it. So this was inside and this was last. Okay, so it looks kind of terrible for one step, and then things start to improve greatly. On the bottom, I have my h, and I have my square root of 3 minus 4h plus h squared plus the square root of 3. And I wouldn't bother multiplying out the bottom. I actually really like the form that's in. That's in a factored form. The h is one of the factors, so I can cancel it whenever I free up some of this. Clean up some of this mess and free up an h in the top. So as bad as that looks, part of it's really nice. The middle two radicals actually wipe each other out. We have positive square root minus the exact same square root, so that's going to be 0. And the 3's drop out as well. I have a 3 minus a 3. So all I'm left with is that negative 4h plus h squared. And I'm going to go ahead and factor out an h since I'm looking right at that. I know that's my next step. So I would say I have h times negative 4 plus h all over h times the square root of 3 minus 4h plus h squared plus the square root of 3. And I then get to cancel the h's. H divided by h is 1. And then as h goes to 0, the top is just going to become a negative 4. The bottom is going to be a square root of 3 plus a square root of 3, which you can improve on even more. So I'm going to say a prime of negative 2. Ooh, I'm going to write a little extra sneaky step in here. So the root 3 plus root 3 is a 2 root 3, which means I actually have 2 more steps. I can then cancel out a 2 and say this is negative 2 over the square root of 3. So that's my answer to part A. So please really try and make these nice, neat, and organized. I need to be able to see what happened. This is really about process. It's all about, do you understand how to compute these things? And it's really important that the limit shows up every time until you actually get to let h go to 0. So it's very deliberate that here I said I still need to let h go to 0, and here I didn't because it had already happened. So I'll be looking for this notation to be correct when I'm reading tests and homework. Okay, so now that we've done the big part, part A, I would like to look at part B. And let's see what's going on here. Find the equation for the tangent line to A when k equals negative 2. Okay, so we already know the slope. The slope is a prime of negative 2, which is negative 2 over the square root of 3. So if you're asked for the slope of the tangent line at k equals negative 2, that's the exact same thing as being asked for a prime of negative 2. Okay, and then we also need a point, and to get the point, we have to plug the negative 2 back into the original function. So this is not a prime of negative 2, it's a of negative 2, which is going to be the square root of negative 2 squared, which is 4, minus 1, which is 3. So it looks like our y value is square root of 3 as well. So our point is negative 2 square root 3. Okay, and then we'll go for a slope intercept form, or a point slope form even. Y minus our y value, which is root 3, equals m negative 2 over root 3 times x minus our x value, which is 2, negative 2, so that'll become a plus 2. Okay, so this is a little messy, but that's okay. I get negative 2 over root 3 times x minus 4 over root 3 plus root 3. And I'm actually fine with that, but I will say that you could do a little bit of cleanup here. So let me do a different color so you can see that this is some scratch work. Negative 4 over root 3 plus root 3. You could rationalize the denominator there. Root 3, multiply top and bottom by root 3. And you would get negative 4 root 3 over 3. And then you could make this a 3 root 3 over 3. So if you add those up, again, I would be fine if you don't do this last step, but you can. It does make it a little nicer. You get negative 2 over root 3, and then you'd have a negative 4 root 3 plus 3 root 3, which is minus root 3 over 3. So it is possible to do that combining at the end. Okay, so I did sneak in one last little piece here because this function is kind of a cool one. So I just want to go ahead and, oh, we're supposed to check that graphically first. So let's do that and then we'll take advantage. Okay, I have a square root of x squared minus 1. I don't need that parenthesis. We are interested in, what was our point? Negative 2 square root of 3. So let's go like Oh, well, here I'm going to go negative 20 to 20. So we'll go big. We'll go negative 20 to 20 on the x-axis, and we'll make our tick marks 2. And then we'll go negative, I don't know what I want to do, 40 to 40 on the y-axis, and we'll make our tick marks 4. I probably don't even need that. Let's go negative 25 to 25. I'm kind of cheating because I do have some idea of what this thing looks like. Okay. So that's what it looks like. And there's a little chunk in the middle that's just straight up missing. If k is between -1 and 1, then the square root, we get the square root of a negative number. So there's nothing in there. But otherwise, it kind of looks like an absolute value. So we are supposed to use our calculator to investigate a little bit about the slopes. So this gets a little less inspiring when you've already seen the picture, but we can still write it down. So at negative 20, our slopes are negative 1.001-ish. At negative 10, it's 9.95-ish. Negative, I hope. X equals negative 10. Oh, freaking me out. dy dx at x equals negative 10 is negative 1.005, and then dy dx at negative 5, negative 1.021-ish, 6, negative 2, negative 1.156. Okay, and then if we do the other side, sorry, I'll try and be speedy. 6. Okay, we want positive 2, which is 1.156, and then we want, 1.155 even. We want positive 5, which gives us 1.021-ish. We want, calculate 6. Okay, 10, which gives us 1.001, and then last one, 20, which gives us another 1.001. Okay, close enough. So basically what I wanted you to see with this, we got it from the picture so it was a little less exciting, was that the slopes, if we look as we get further and further away from the middle of that thing, the slopes are getting closer and closer and closer to 1. So it's not just that this thing looks like the absolute value of x, it's really close, maybe more like to the absolute value of x minus 1. So if that's the absolute value of x minus 1, it's starting out just a little bit with a slope a little bit steeper than 1. So it's coming up from 1, 0, a little bit steeper than this thing, and then the slopes get closer and closer to 1. And then it's just a mirror image on this side, starts a little higher, and then it drops in. So it's kind of a cool shape. It's almost like an absolute value, but it's got its little corner shut off. And then it curves a little bit at the end and then gets really, really straight. All right, thanks for watching.